So this tutorial is explaining how I solved the Rubik's 4x4 on my own back in 1982. I had a Rubik's Cube in 1981, like many of my friends in high school, and there were two articles in Scientific American about Rubik's Cube, and as soon as the 4x4 became available, I bought this 4x4. You can see it has the old color scheme with white opposite blue, and the original Rubik's Cube was like that too. It had white opposite blue. Anyway, no one in my high school had a 4x4. I didn't have access to email to communicate with the Cube Lovers mailing list, so I figured it out myself. And so we're going to explain how I did that. Step 0 is to spend a while trying to get one side. This is something almost everyone who's really interested in working out the puzzle themselves, they'll start with that. And that's about all I'll say about that. Now, step 1 is to figure out a way to change just one piece on the top, and then write it down. So let's look at the cube here. Let's say we want to put this green and orange piece right here somewhere on the top. So what can we do to do that? Well, let's see. There's a couple ways you can do it. You can move it over. Let's see. We can move this down. We can put the green and orange one there and put that up. That's 4 steps. I don't know. Maybe. How about if we bring this side down, put our green and orange piece into it, that, and bring that up. Well, that's pretty good. That's only 3 steps. So that's what I'll use. So then, I had to invent a way to write it down. It had notation for the 3x3, but not for the 4x4. So the way I decided to write this was okay, well, let's see what we do. So we turned our left hand to the right, and that was the same as a 3x3. We did call that L back in those days. And then this, I called that U sub 3. Now it's called a little d prime, but third layer down from the upside. That's why I called it that. And then L and L prime, and there we go. So that's what I did. I put the piece on the top. So that's step 1. Now for step 2. Step 2 is to create a commutator. Easiest way to make an algorithm is with this thing called a commutator. And the way the commutator works is you do something else, then you undo the first thing, and then you undo the second thing. PQ, P prime, Q prime. Not sure where those P's and Q's originally came from. So P is going to be getting the piece on the top layer, which is what I just did. Q is just change the top by turning it. And now let's put the rest of the cube back. So let's undo the thing we did to get that piece up there. That'll fix the bottom of the cube. It's messed up now, but it would have, if it was solved down there, it would have been messed up by what I did to put that piece in the top. So we're going to undo what we did to put the piece in the top. And then the last step is actually to just turn the top back to fix, the rest of what it was on the top. So let's write these down. So P, and now I'll use the modern notation because you get the point on the fact that I invented my own notation. That doesn't matter. So we're just gonna, that's what we did to put the piece on the top. Q is we turn the top layer. Undoing those first 3 moves is of course L, D, L little d, L prime, and then U prime. There you go. So that's our algorithm. That's an algorithm. We just created an algorithm. So I think I put the green and orange piece up, and I did turn the U, so I'm at this point now. So I want to do my L, my little d, and my L prime, and then my U prime. And might be a little hard to tell what happened here on the cube, but basically what happened is the 3 pieces got moved. And to show that, we're going to get a fresh cube. We'll use the East Sheen for this. So here's the L, D prime, L prime, and here's the U, and then there's the L, D, L prime, U prime. And this is what changed. The green and yellow ends up here, and the red and white ended up over there, and the green and red ends up down there. So having no standard system for describing the locations of pieces and things like that, I just, kind of drew a picture of a cube, and, I made a little, let's see, that piece, call that A, and, piece A came from over here, so I, kind of drew an arrow, and I don't know if you can see that in the video, but, I did that kind of thing, the kind of thing you'd expect. And then I learned it. As I was trying to solve my cube, I just kept looking at this and saying, all right, well, I need to put the green and white one up there. So, where is the green and white one? Well, there it is. And well, let's see. Let's look at this. So it's going to make it go from here to here. So that means I need to have it so that it's like first piece is down there and the place it's going is up here. And then I do this, and here we go. Well, let's bring that back and go back, and I've solved the green and white. And that, that's it. That's the biggest part of this. Now, next step is to adapt it. I have a way to move a piece from here to here to here, and that's great, but it would be nice if we had a way to work with pieces that were all in one side. So here we've got three pieces that are all on one side, and you can see that these three pieces that are all on this side are actually the three pieces that my algorithm changed. So, and all I did to make that happen was, I just did a turn of the right-hand side of the cube. So you take this raw algorithm, and then you make it more useful by making it into something that can be used to solve the last layer, for example, or something like that. I actually ended up developing a cage technique. So I was pairing up my edges, kind of any way I wanted to, and the last thing I did was solve my centers. But modern day cube solving, you would be trying to use one layer techniques. So adapting this algorithm to work on the top layer is R prime, and then all of this, which maybe by now I've learned, but writing it down, L prime, U, L, D, L prime, U prime, and then, as you might guess, R is bringing it back up to the top layer, which is where it came from. So let's try that algorithm. We're going to use another fresh cube for that. Got plenty of cubes here. This algorithm is going to move these three pieces in a cycle these three pieces on the top layer. So R prime, L, and D prime, L prime U, L D, L prime, U prime R. And there it is. I've moved three pieces around. And that's very similar to the type of algorithm that we use on a 3x3, except that on the 3x3, when you're moving three pieces around, it only takes 7 turns, assuming you count this centered splice thing as one turn. And this thing we've created here for the 4x4 is 10 steps. So, maybe it's a little less efficient, but I really cared about solving the cube and understanding how to make patterns like on those cubes, and I didn't care at all about speed cubing or get my times down past, say, 10 minutes for the revenge or something like that. It's quite easy to accomplish, and that's all I needed to do. So that's the basics of it. You have a way to move three pieces.